Hello class, welcome to today's lesson, and the objectives for today will be the following. We will find a formula to find the slope of the tangent to any function f at any point. So we cannot get any more general than this. And the second thing, we're going to define the concept of the derivative of a function. So let's start. Okay, if you remember from the last class, what we did was, I'm gonna briefly sketch what we did in here. What we did was finding for the specific function x squared, f of x equals x squared, we found how to get the slope of the tangent at point 1 comma 1, right? You remember that? We said, okay, we want to find the slope of this tangent that goes through this point, and we did. Okay, and I told you that the concepts involved in this are somewhat difficult. You have to study them slowly, etc. And if you remember how we did this process, is that basically we used another point over here, any other point. We call this point 1, point 2. And what we did was getting the slope of the second, right? The second going through P1 and P2. And then we approached the point P2 towards P1, and we said that as P2 approached or approaches the point 1, we can say that the slope of the second will eventually become the slope of the tangent. So the whole process, all of these things, is basically a limiting process. And that's why we studied limits at the beginning of the course. Okay, now I want to generalize. Oops, sorry about that. I want to generalize this idea. Okay, I want to find the slope of the tangent to any function at any point. Okay, I don't want to be talking specifically about the function x squared. I don't want to be talking specifically at this point 1 comma 1. I want to be as general as possible, and that's the best thing in mathematics. Mathematics is about being general. You don't want specific cases. You want the real deal, the whole idea. Okay, so let's start. Okay, I'm gonna draw a Cartesian plane. This is my axis for x. This is my axis for the values of the function. And what I'm gonna do is draw any function, whatever. I'm not really saying what function this is. Okay, it's just a function. What function is it? I don't care. I don't care because I'm talking in general terms. Okay, and the goal for today is to find a formula that could give me, for example, the slope of the tangent to this function at this point. Okay, at the point, let's call it x1 and f of x1. Remember, I cannot give specific about these two values because I'm being completely general. So the point x1 comma f of x1. What if I want to find the slope of this tangent that goes through this point? Okay, or what if I want to find the slope of the tangent that goes through this point? Okay, through the point x2 comma f of x2. You see this tangent that goes over here, which would look a little, this is complicated, little like so, more or less, or any other point. Okay, what if I want to calculate the slope of the tangent to this graph that goes through this point, x3 comma f of x3? You get the idea, right? This tangent. Okay, I want to find a formula with which I can find all of these slopes, okay, at any point I please, x1, x2, x3, whatever, okay, any point. And we're gonna do that right now. So once again, I'm gonna draw the same diagram. Try to be as straight as possible. There you go. The axis for the x, the axis for my values of the function f of x, the same general function. I don't care what this function is. And let's draw any general point. Let's talk about this point. The point which has x as its first coordinate and f of x as its y coordinate. Okay, and let's call this point 1. So point 1 has two coordinates, which are x and f of x. Good. And I want to calculate the slope of the tangent that goes through this point. So that tangent would look like so, more or less. Perfect. Okay, so how do we do that? We recur to our second line. Remember, we're gonna locate another point over here. It can also be over here, okay? Don't get me wrong. It can be anywhere as long as it's not P1. So this other point, let's call this point P2. And let's trace a vertical line that cuts the x-axis. And let's trace a horizontal line that cuts the y-axis. And let's call this region, like I said before, this little space in here, this length of this segment, let's call it h. All of this is going to be h. And h in mathematics, in this context of calculus, h is called the increment. The increment. Okay, so basically, if the distance from the origin to this point is x, clearly, right? Because I mean this mark is x, so from here to here is x, and the length from here to here is h, the length of this segment, then clearly this little mark in here, or this number, should be x plus h. It's x plus h, x plus h. So this number here is x plus h, and its corresponding value for the function, which is over here, should be f of x plus h. Perfect. Okay, and now let's draw the second line that goes through P1 and P2, because remember that we need to use the second line in order to find the slope of the tangent line. So I hope it comes in the first try. Perfect. So let's call this S for second and T for tangent. Perfect. We're doing very well, guys. Now, remember, what is the whole idea about this? What is the core concept? The core concept is this, that as P2, as I approach P2 towards the point P1 in this fashion, in this way, you know, try to imagine P2 going all along the yellow line, like so. And try to imagine how this diagram would change, okay, all these vertical lines and all this stuff as I do that, okay? That is I need you to imagine it, okay? You see? So as P2 approaches P1, the second line approaches the tangent line, and we can say, or we can write the following. As P2 approaches the point P1, then I can establish that the slope of the second approaches the slope of the tangent, which is what I'm looking for, right? Another way to say the same thing, this exact same statement, is the following. It's an equivalent way. If you notice, as P2 approaches P1, And I told you, try to imagine how the whole diagram would look as you do that approaching. Okay, this vertical line obviously will move towards the left, and this increment h will be shorter, right? It will diminish, it will decrease. Okay, it's gonna get smaller and smaller and smaller. H will get smaller and smaller as p2 approaches p1. So this statement that I wrote here is equivalent to this one. As h approaches 0, then I can conclude the same thing. The slope of the secant approaches the slope of the tangent. You see, these two statements are completely and 100% equivalent. Okay, now let's talk about the slope of the second line for a moment. The slope of the second line. By now you should know how to calculate this thing. Okay, you just use the formula y2 minus y1 over x2 minus x1. So this is my second line, this is my point 1, this is my point 2. So if I do this, then an equivalent way to write this once I substitute is the following. Y2 is the y coordinate of the point 2, which is this one, right? F of x plus h minus the y coordinate of the point 1. This is point 1. This is its y coordinate over the x coordinate of the point 2. This is point 2. This is its x coordinate, x plus h, minus x1, which is x. Okay, let's go over this zone to the right and let's continue. Then the slope of the second will basically be all of this, and after you simplify the denominator in here, you will get h, right? That's very simple to see. So we get this. Okay, so this quotient, guys, this division gives me the slope of the second. Okay, and we have already done this before. Okay, perfect. So now basically we are about 2 or 3 minutes from the end of this process. Okay, now what else can I say? Remember, we're looking for the slope of the tangent. Okay, now I can affirm that the slope m of the tangent is equal to the slope of the secant as h approaches 0. And that is a limiting process. Okay, that's a limit. So I'm going to establish the following. The slope of the tangent will be equal to the limit as h approaches 0 of the slope of the secant. But what is the slope of the secant? It's all of this quotient. So I'm going to substitute. I'm going to open brackets. Okay, so basically this is the formula that gives me the slope of the tangent. You see, it's a limit. It's the limit as h approaches 0 of this weird quotient. You're gonna get so familiar with this quotient that, you know, if you think that this is complex or weird, by the end of the course you will see this as, you know, completely familiar to you. Okay, now I'm gonna do something weird now. Even weirder, you know. I'm gonna do this. Look, I'm gonna write this sentence. Let's represent the slope of the tangent to the function f at the point x right here. Okay, you see this is the tangent, and the tangent has as point as one of its points x comma f of x. So that's why I'm writing this. Let's represent the slope of the tangent to the function f at x. All of this phrase, I'm going to be representing it by the symbol, this one, f prime of x. That's how this is read in mathematics, okay? I'm going to repeat. F prime, like like Amazon Prime, f prime of x. That's how you read this. And that's how you read it. What does it mean? The slope of the tangent to f at x. In a way, it's kind of like if this apostrophe or this little symbol could be read as this. Look, the slope of the tangent to the function f at x. You see? So you're basically putting together all of these phrases in quotation marks, all of these words into this little symbol. They mean exactly the same. So if I do this representation of this phrase by this symbol, then basically I can do this. Look at this at this equation, and I can do the following. Then the slope of the tangent to the function f at x will be equal to the same thing, right? Because this is the slope of the tangent. You see, mt stands for the slope of the tangent. But it requires more information, because if I just write this, it's not enough information. We're trying to get the slope of the tangent to the function f at this point x. That's why I devised this new symbol. You see, it's basically the same. This and this is the same, but this symbol carries more information. It carries the information about the function and about what point you're considering. You see, mt is not that good. So that's why I'm devising or creating this new symbol. So basically, all of this will be written here one more time. The slope of the tangent of f at x is equal to the limit as h approaches 0 of the same quotient, f of x plus h minus f of x over h. Okay, and we are done, guys. I'm gonna highlight this formula. I want you to write it down anywhere. We're not really using a notebook or anything, but write it down momentarily, because we're gonna use it in a moment. This is one of the most important formulas for us in the course, probably in the top 3 or top 4. Okay, I'm gonna read the whole thing for you. F prime of x is equal to the limit as h approaches 0 of this whole quotient. I don't have to read this. Another way to say the same is the slope of the tangent to the function f at x is equal to the limit as h approaches 0 of this whole quotient. Please write this down. And now we're gonna put to use this fantastic formula. Okay, let's use it. Okay, so how can I use that formula? Remember that we were working with the function. Remember that we were working with the function x squared, right? F of x equals x squared, and we were trying to find the slope of the tangent at the point x equals 1 and f of x equals 1. Okay, this tangent. Okay, we're gonna do the same. We're gonna get the slope of this tangent, but now by using our recently discovered formula. That's what we're gonna use. We're gonna do exactly the same, and you're gonna see how quick it is to find the slope of the tangent to any function at any point. So the example could be written in this way. Example, find the slope of the tangent to the function f of x equals x squared at number 1, at the point x or at the value x. Number 2, at the value x equals 2. This is the one that we have done before. We know what to expect out of this. Number 3, at x equals 3. And number 4, at x equals minus 2. Okay, so basically the first thing is getting the slope of the tangent to this function at any point x in general, and then for specific values of such function. Okay, what are we going to use? We're going to use the recently discovered formula. So here goes the solution. I'm going to do it over here. So the formula that we just discovered, I repeat, is this: f prime of x, or the slope of the tangent to the function f at point x, is equal to the limit as h approaches 0 of this quotient okay, and we just have to follow the formula. Just follow the formula. You see, let's start. F prime of x is equal to the limit as h approaches 0 of f of x plus h. If f of x is equal to x squared, then f of x plus h will clearly be x plus h to the square minus f of x. What is f of x? Is equal to x squared. Over h. That's it. Next step, f prime of x is equal to the limit as h approaches 0 of this binomial to the square. I'm going to raise it, x squared plus 2xh plus h squared minus x squared over h. We continue, f prime of x equals the limit as h approaches 0 of, when you simplify the numerator, you will get 2xh plus h squared over h. Continue. And then, like I said before, also in the video before, in the past video, we can divide both the numerator and denominator over h. And you will get, after you do that, you will get this value, 2x plus h. You see? And the reason why you can divide both numerator and denominator by h is because h is never 0. H only approaches 0. You see, that's why the concept of limits, the limit is so important. H never touches 0. It only approaches it. Because if h was 0, you could not have gone from here to here, because the division of anything over 0 is not possible. If I'm dividing this over h and this over h, and h is 0, I would be performing a forbidden operation. But hey, h is not 0, so I'm perfectly fine doing it. You see, that's why this concept in here is so important, guys. Okay, and that's it, guys. Now what's the next thing? Remember, if I'm trying to get the limit of some function or something, and if I just can evaluate and nothing weird happens, for example, if h approaches 0, and if I put 0 here, nothing weird happens, no division over 0, then basically what we have found is that f prime of x is equal to 2x. Once I calculate the limit of this thing as h approaches 0. I'm done, guys. This is the cherry on the cake. This is what you wanted to get at. Okay, after you do all this process, you find that f prime of x is equal to 2x. And what does that mean? Let me translate that for you. What this means is this: the slope of the tangent to the function f at the point x should be equal to 2x. And what is my function in this problem? My function is this one. You see? For this particular function, for the function x squared, if you want to calculate the slope of the tangent to this function at any point x, all you do is multiply 2 times x and you will get that slope. That's it, guys. That's it. In here, I'm going to do this diagonal here, and we're going to do 2, 3, and 4. So once I have the most general formula for the slope of the tangent to this function at any point x, now it's only a matter of substituting these proper numbers of x, 2, 3, and minus 2, in order to get the slopes at these values, 2, 3, and minus 2. For example, the first one, okay, this is number 2. What's going to be the slope when x equals 2? Well, the slope will be f prime of 2. You see, I'm just substituting, equals 2 times 2, I forgot, which is going to be equal to 4. This is my answer for the slope of the tangent to this function at the point 2. Okay, which it's 4, which is what we have already found in the previous video. Try to make sure about that. Okay, so this is the first answer, 4. The slope is 4. Now, number 3, when x equals 3, what's going to be the slope? Well, I just calculate f prime of 3 equals 2 times 3, and it's going to be 6. So this is my second answer. What this is telling me, the translation of this into language, normal language, is this: the slope of the tangent to the function f when x equals 3, or at the point whose coordinate is 3, whose x coordinate is 3, will be 6. And we're going to check that in a moment. And finally, for the last one, when x equals minus 2, what's going to be the slope? I just evaluate this formula in minus 2, and I'm going to get 2 times minus 2, which is minus 4. So this is telling me that the slope will be minus 4. Okay, so remember these numbers: 4, 6, and minus 4 for the values 2, 3, and minus 2. Okay, write them down. Write them down, because I don't want you to memorize. Write them down. For x equals 2, x equals 3, and x equals minus 2, you get the slopes 4, 6, and minus 4. And now let's check whether this thing is actually working or not. Okay, we're done with the writing. Now let's just check these values. Okay, I want you guys to go to this. I want you to type in Google, type recta tangente y recta secante y GeoGebra. Así quiero que tecleen en Google. Agradezco al autor Miguel Hernández. Este no es mi trabajo, es de me imagino que es un profesor. Y asumo que esto es para el público general, ¿verdad? No veo ninguna marca que diga que no estoy autorizado a hacer esto. Este paquete de GeoGebra es libre, es un software libre, así es que estoy asumiendo eso. Entonces, Miguel Hernández, gracias por tu cooperación. Si quieres que quite este video, pues me dices, ¿verdad? Porque estoy abusando tal vez de la confianza. Ok, entonces, chicos, quiero que entren a esta página. Como les comento, nada más tecleen recta tangente y recta secante y le ponen también GeoGebra y van a hallar este applet. Ok, vamos a abrirlo. Muy bien. Aquí, esta no es la función original que les va a aparecer. Oh, by the way, let's go back to English. I'm sorry. This is not the original function that will appear. Okay, it's going to appear another function. I want you to type this function, f of x equals x squared. Okay, that's the first thing I want you to do. Okay, and then what I want you to do is this. This applet, basically, what it does for you, I think something got erased. Okay, yeah, no. I was mistaken. What this applet does for you is that it lets you put a point over the graph, point A. There was another point here, B, but I already erased it. Okay, so you have to erase the point B. All you have to do is this: click on the point and borrar. Okay, that's it. And the second point that you will observe, point B, will be erased because that point is not necessary for us right now. So the point A, if you notice, is the point through which the tangent to this graph goes through. Okay, so basically we have the function x squared and several tangent lines that we can vary or change. Can you see? It's very nice. You see, this is the point. These are the coordinates of your point A, and this line, this is the equation of the tangent line. Okay, you see. And remember that this form of the equation is called slope intercept. This is the slope of this tangent line, and this is the intercept with the y-axis. So what did we want to check? We want to check the slope of this tangent line at what point? At the point whose x coordinate was 2. Okay, so let me put A in such a way such that this coordinate is 2. So let's do it. There it is. Okay, the point 2 comma 4. Okay, so what is the slope of this thing? Let's look at the equation. There it is. It's 4, like we said. You see? So for the first case, it checks. Perfect. Nice. Okay, you can move this around. You know, you have to play with the apple. You have to get to know it. Now let's put what is it? What was the second value? The second value was 3, right? Yeah, it was 3. So let's put A such that the x coordinate will be 3. We're close. Let's move it. There it is. You can also work with the keyboard with the arrows. There it is. I'm using the arrows in order to move very slowly. Okay. Right now I'm typing left arrow, right arrow, and so on. So at that precise point, 3,9, you see, now the slope of this tangent to my function is this number, 6, which also was the number that we got. You see? So that formula, well, never mind. That formula that we found, f prime of x equals 2x, is a general formula. Once you have it, you can use it to find the slope of any of these tangents. It doesn't matter which one. And you can get it in I mean, like 5 seconds, right? And the other point was the point whose x coordinate was -2. So let's put A in that point, in that coordinate. This should be -2 now. And there it is. Let's check the slope of the tangent, and it's telling me that it's -4, which is the number that we also got. So you see, guys, everything checks perfectly. We have found a way. Okay, I'm gonna be done with this. You're gonna be using this in a moment as in the homework. I'm gonna tell you what that's gonna be. So let's get out of here. So this formula, okay, that we got by following this very general formula. Okay, once we use this, which is the general formula to get the slope of any tangent line to the function f at any point x. Okay, once we wrote this and we followed the steps and the algebra and so on, it allowed me to calculate this other formula specifically for the function x squared. But if I want to use any other function, Then I just apply this formula accordingly with any other function that I may have, and I'm going to get a specific formula for finding the slope of the tangent of f at x, and I'm going to find something different in here, specifically for that function that you have in mind. Okay, it can be the function x to the cube, or the function x to the 4, or the function x to the cube plus 2x squared, any function. This thing, guys, this is the general idea. Okay, this is the general thing. Okay, I think I'm gonna stop it right here because I observed that that was plenty of time. um, I'm gonna stop. I'm gonna tell you what the homework will be, and we're gonna talk about the derivative on Monday. Okay, I don't want to do it today. That was enough for today. So that's it, guys. I hope you have understood how this extremely general formula works. And thank you.